Hi, chemistry students. Let's talk about the concept of pressure, because we now have a relationship which says this thing called pressure, when we multiply by the volume, is equal to the number of moles of the gas inside of a container times some constant R and then the temperature of that container. Just to be sure that we know what everything is, the pressure is the pressure of the gas. Okay, so what do we mean by this? We mean it's the pressure against the container walls. The volume is equal to the volume of the container itself This is important because molecules themselves have a volume, and therefore we have to distinguish between the two. Once again then, N is equal to the number of moles of gas. And the temperature should be the temperature of everything. So the temperature of both the gas and container, they should be at the same temperature. So here's what we've got in terms of this relationship, but we really haven't decided or mentioned what this pressure is and how it all relates. And if we do that, we might be able to go a step further later on and use theory to come up with a relationship. Because if you remember correctly, this is an empirical relationship as of right now. All we did is we looked at experimental evidence to get this relationship between the variables, P, V, N, and T. What we're looking for now is a gateway to using theory to come up with another relationship between pressure, volume, the moles, and the temperature. And if they're the same, then we've got a really good sound theory. Otherwise, we may have to adjust our theory to match reality. So experiment is going to be our reality. It's real, but we can also have a theory, an ideal theory, and see how that works. That's coming up next. For now, let's think about what is causing this pressure. What is pressure? And in physics, they define the pressure as the force per unit area. Mathematically, just so you know, that means that the pressure is defined as the force divided by the area. That per is really meaning a division divided by. So what's the pressure? Well, it's this force per unit area, and a force is just a push or a pull, and the only way that molecules can push or pull on a wall is to bump into them. So for us, this implies immediately that the pressure is caused by collisions between the gas particles and the walls of the container. Well, right there, we've got an idea of how this whole thing works. And that's going to be our connection to the next level when we get there. For now, we need to understand that pressure then is some kind of set of units, and there's a whole bunch of different kinds, and we have to recall what those are. And it's measured in a variety of ways. In the animation I showed you in the first video, it was measured in PSI, which stands for pounds per square inch. That's an English unit that we won't use. The SI unit for pressure, in SI units, it's the Pascal. That's the SI. The more common unit that we use nowadays in chemistry and science is the atmosphere. This is a very common one. And there are some others that are traditional. There's the millimeter of mercury, okay, and the torr. And they're just traditional. So these all have a nice little simple relationship between them, and it kind of goes like this. There are 760 torr in 1 atmosphere. There's also 760 millimeters of mercury in 1 atmosphere. So that tells you that a torr and a millimeter of mercury are the exact same thing. Torr is short for the gentleman Torricelli who did these initial experiments. And then the last one's very odd, and that there's 101,325 pascals is 1 atmosphere. Yeah, so these will be usually given to you, but it's not a bad idea to put some of this into your head. Makes it a little bit quicker to get it. You don't have to look it up on tests and such. But it should be given to you whenever you take this, take an exam or a quiz or anything like that. There you have it. So pressure, the key thing is it's caused by collisions between gas particles in the walls of the container. And we're going to take that to the next level and make that into a theory and see if it matches what the experiments gave us.